Here we have a polar region generated by the graph of r equal to 1 plus 2 sine of theta. And so the graph, it has what's called an inner loop, and we want to find the area of this the region inside right here. So we don't want the whole thing, we want the area of this inner loop right here. And so to figure out the area of this inner loop, we have to figure out where it starts. It starts at what alpha and ends at what beta. And so we can see that this inner loop right here, it starts at the pole, and then it goes around, and then it ends at the pole. And so inner loop, so let's make a note of that. It starts and ends at the origin of the pole, where r is equal to 0. And so to find where the inner loop starts and ends, then we just set r equal to 0. So we have this is equal to 0. And then subtract 1 from both sides, we'll get 2 sine of theta. Is equal to negative 1. And then divide both sides by 2. Then we get sine to be negative 1 half. And we go to like a trigonometric table values, then we will find that sine of 7 pi over 6 is negative 1 half, and that sine of 11 pi over 6 is also negative 1 half. So what this tells us is that sine, that theta is equal to 7 pi over 6. And 11 pi over 6. And then now we go back to the graphing calculator and set the calculator from theta minimum, which is alpha, at 7 pi over 6, and then set theta max, which is beta, at 11 pi over 6, and see if we get the inner loop or not. If not, then we just have to try something else. And on the graphing calculator, we set the calculator from 7 pi over 6 to 11 pi over 6, and we see that we do get the inner loop. And so area of inner loop. Is going to be this. And then so alpha will be 7 pi over 6, and then beta will be 11 pi over 6, and then r of theta will be 1 plus 2 sine of theta. And then again, for something like this, if we used a numerical integration method like trapezoid's rule, then this will give us 0.54351646. So we're using the numerical integration method like trapezoid's rule.